Hello everyone, welcome to our channel. In today's video, we are diving into Interview Ready, Learn DBMS Fundamentals. Your quick guide to learn DBMS concepts and cracking interview questions with confidence. Let's get started. Explain the concept of a B-tree and B+tree in DBMS. B-tree is a self-balancing search tree in which nodes can have multiple keys and children. It maintains sorted data and allows searches, sequential access, insertions, and deletions in logarithmic time. B-tree has following properties. 1. Every node contains multiple keys. 2. Keys are sorted within each node. 3. Each internal node with k keys has k+1 children. 4. All leaf nodes appear on the same level. 5. Nodes split, merge to maintain balance after insertions or deletions. B-tree is used in following cases. 1. Indexing in databases. 2. File system. 3. B-tree is good for general searching. B+tree is an extension of the B-tree where internal nodes only store keys, not actual data. Leaf nodes store all actual data records and are linked for efficient range queries. B-tree has following properties. All data is found at the leaf level only. Internal nodes guide the search process. Leaf nodes are linked, like a linked list, for fast range queries. More compact internal structure means better caching. B+tree is used in following cases. Most relational databases use B+trees for indexing, e.g., mysql, postgresql. B+tree is optimized for search plus range queries. Explain the concept of data partitioning in DBMS. Data partitioning is the technique of dividing a large table or database into smaller, more manageable pieces called partitions. These partitions act like individual tables, but they are accessed and managed as one. Partitioning is done to improve performance, scalability, and manageability of large datasets. Types of data partitioning: horizontal partitioning, sharding, splits rows into multiple partitions based on a condition, e.g., region, date. Vertical partitioning, splits columns into multiple tables to separate frequently and infrequently used data. Range partitioning, splits rows into partitions based on a range of values in a column, e.g., dates or amounts. List partitioning, splits rows into partitions based on a specific list of values in a column, e.g., region names. Hash partitioning, splits rows using a hash function on a key column to distribute data evenly. Explain the concept of transaction isolation levels. In a multi-user database, multiple transactions often run at the same time, concurrently. Transaction isolation levels define how isolated one transaction is from others, especially in terms of reading or writing the same data. Isolation levels are part of the ACID properties, specifically the I in ACID. Without isolation, we may face problems like dirty reads, reading uncommitted data from another transaction. Non-repeatable reads, same query gives different results in same transaction. Phantom reads, new rows appear when the same query runs again. Types of isolation levels: read uncommitted, allows reading uncommitted changes from other transactions. Dirty reads, fastest but least safe. Read committed, only reads committed data, prevents dirty reads but allows non-repeatable and phantom reads. Repeatable read, ensures same rows return same results throughout the transaction, prevents dirty and non-repeatable reads, but allows phantom reads. 4. Serializable, highest isolation, completely prevents dirty, non-repeatable, and phantom reads by executing transactions as if they were sequential. What is a transaction log in DBMS? A transaction log, also known as a write-ahead log, is a special file in a DBMS that records all changes made to the database before they are actually applied. Purpose of transaction log: recovery, helps restore data after a crash or failure. Rollback, allows undoing incomplete or failed transactions. Durability, ACID, ensures committed transactions are not lost. How it works: log first, DBMS writes the change to the log file. Apply change, then it updates the actual database. Commit log, marks transaction as complete. Durable, simple analogy, like a flight black box, a transaction log records everything so the system can recover or replay what happened, even after a crash. What are the different types of database locks? Locks are mechanisms used to control concurrent access to data in a database, ensuring data integrity and consistency. Here are the main types of database locks. Shared lock, S, allows multiple transactions to read the data but prevents writing. Exclusive lock, X, allows a transaction to read and write the data, blocking others from accessing it. Intent lock, indicates a transaction's intention to acquire a lock on lower-level data, like a row in a table. Row-level lock, locks a specific row, allowing high concurrency. Table-level lock, locks the entire table, restricting access for all rows. Read lock, permits reading by multiple users but prevents writing. Write lock permits only one user to write, blocks others from reading or writing. Deadlock, a situation where two or more transactions wait indefinitely for each other's locked resources. What is a two-phase commit in DBMS? Two-phase commit, 2PC, is a protocol used to ensure atomicity in a distributed database system, where a transaction spans multiple databases or systems. It ensures that either all systems commit the transaction or all roll it back, keeping the data consistent. Phase 1 Prepare, voting phase, the coordinator asks all participants if they're ready to commit. Each one logs data, logs the intent, and replies, yes or no. Phase 2 Commit, abort, decision phase. If all say yes, the coordinator tells everyone to commit. If any say no, it instructs all to roll back. Two-phase commit ensures atomicity across multiple systems. No system commits unless all agree. Drawbacks, blocking protocol. If coordinator crashes during commit, participants may be stuck waiting. Slow in high latency environments. What is the role of a transaction manager in a database? A transaction manager is a core component in RDBMS responsible for ensuring that transactions are executed correctly, safely, and according to asset properties. Key responsibilities: begin, commit, rollback transactions, starts and ends transactions, or rolls them back in case of failure. Ensure atomicity, makes sure all operations in a transaction are either fully completed or fully undone. Maintain consistency, coordinates with the database engine to preserve data integrity before and after transactions. Control concurrency, manages locks and isolation levels to avoid conflicts in concurrent transactions. Handle recovery, works with the recovery manager and transaction logs to restore the database in case of crashes. Communicate with other managers, coordinates with log manager, and recovery manager for full transaction support. What is the difference between OLTP and OLAP systems? OLTP, Online Transaction Processing, a system designed to handle real-time, high-volume transactional operations like inserts, updates, and deletes. Designed for real-time transactional operations, e.g., insert, update, delete. Handles a large number of short, simple queries. Data is usually normalized to reduce redundancy. Optimized for fast write and read performance. Used by customers and operational users, e.g., ATM, order entry. Data is updated frequently and in real time. Focuses on day-to-day business processes. OLAP, Online Analytical Processing, a system designed for complex data analysis, reporting, and decision-making through aggregated queries. Designed for data analysis and reporting. Handles a small number of complex queries involving aggregations. Data is often denormalized for fast querying. Optimized for read-heavy workloads and aggregations. Used by analysts and decision makers, e.g., dashboards, buy tools. Data is updated periodically, daily, weekly. Focuses on long-term business insights. What is a hashing technique in DBMS? Hashing is a data retrieval technique in DBMS that uses a hash function to compute the address or location of a data record directly from its key, enabling fast access. How hashing works: input, a key, e.g., employee ID equals 105. Hash function applies a formula like key equals key%n, where n is the number of buckets and the value of n is based on type of hashing is being used. Bucket address, the result gives the location where the data is stored. Direct access, the DBMS fetches the record from that location in constant time O1. Example, if key equals key%10 and the key equals 105 right pointing arrow 105%10 equals 5 right pointing arrow store, retrieve data at bucket 5. Types of hashing: static hashing, fixed number of buckets, doesn't grow with data. Dynamic hashing, buckets grow or shrink as data increases or decreases. Extendable hashing, uses a directory to manage buckets more flexibly. Linear hashing, gradually adds new buckets to avoid rehashing everything. What are the different types of backups in DBMS? Full backup, copies the entire database, all data, logs, etc. Easy to restore, but takes more time and space. Incremental backup, copies only the data changed since the last backup, full or incremental. Faster and smaller, but restoration needs all incremental files. Differential backup, copies all changes since the last full backup. Grows in size over time, but faster to restore than incremental. Transaction log backup, backs up only the transaction log, used to recover from crashes. Helps restore the database to a specific point in time. Mirror backup, or real-time backup, maintains a real-time copy of the database. Useful for high availability systems. Cold backup, offline backup, taken when the database is shut down. Simple and safe, but causes downtime. Hot backup, online backup, taken while the database is still running. No downtime, but more complex. Cloud backup, backup stored on cloud storage instead of local disk, useful for disaster recovery and off-site storage. Thanks for watching. I hope you found the video helpful. If you liked it, don't forget to give it a thumbs up and subscribe to the channel for more interview-ready content.